All right, so today we're going to be learning about the rational zero theorem. The rational zero theorem basically just tells you that there are integer coefficients inside a polynomial that will give you all of the possible rational zeros of a polynomial. Okay, so last week we learned about finding the zeros of a polynomial, right? By synthetic division, right? By synthetic division or long division, and if your remainder is zero, then that zero is a factor, and then we write the zeros. Yes, okay. So this is just to help you list all of the possible rational zeros, okay? Because last week we were given the possible. Now we have to write them ourselves, okay? So let's talk about the rational zero theorem. If f of x equals some polynomial, that's what a sub n x to the n power is, this represents a polynomial, has integer coefficients, then every rational zero of f has the following form: p over q. P equals the factor of the constant term, which will be the very last term if it's in standard form. And q would be the factor of the leading coefficient, which is going to be the coefficient of the term with the highest degree. Okay? All right, so example 1, it says, using the rational zero theorem, we're going to find the rational zeros of f of x, which is x cubed plus 5x squared plus 2x minus 8. Now, it sounds pretty complicated, but all you're doing is taking the factors from the constant term and putting them over the factors of the leading coefficient. So the factors in the constant term of this polynomial is -8, and the leading coefficient would be 1 because we don't see anything in front of x cubed. All right. So the leading coefficient is 1, and the constant term is -8. So all of the possible rational zeros are going to be factors of -8 over the factors of 1. Factors of -8. What makes -8? You got 1 and 8, or 2 and 4, right? What we're going to do when we list our rational zeros is we're going to add a plus or minus in front of all of them. Okay? Because you could have a positive 8 and a -1, or you have 2, or you could have a positive 2 and a -4. So we have to account for that by using the plus or minus. Then you have the coefficient. Then you have the coefficient of x cubed, which is 1. And the only factors of 1 are 1. And we're going to make it a plus or minus. And then all you have to do is make fractions with them. Okay? So all of our x's, they're going to be, let's start with the first factor of -8 plus or minus 1 over 1. And that 1 comes from the leading coefficient. So all of our denominators are going to be 1 because our leading coefficient is 1. Yes, awesome.
So you don't have to put the plus or minus for the bottom one?
No, this plus or minus will cover both of them. Okay, good question. All right, so then we're going to keep listing plus or minus 2 over 1, plus or minus 4 over 1, and plus or minus 8 over 1. All right, so usually after you find, I'm just talking to everybody. You don't have to say anything right now. I am recording. I'm recording. Okay, no, I'm recording. All right, so usually after you list all the possible rational zeros, they'll ask you to test some to find out what the zeros are. So you can test them using synthetic division or long division, or you can test them by using your calculator. Okay, so we'll do long synthetic division with this one because it's easy enough. But on the next example, I'm going to show you how you can test it in your calculator. All right, so we're going to test x equals 1. So we're going to put 1 on the outside. The big L is already drawn for us. Then we're going to drop down and multiply. Alright, so drop this 1 down, multiply, 1 times 1 is 1. Drop this down, 5 plus 1 is 6. Multiply, 6 times 1 is 6. Drop that down, 2 plus 6 is 8. 8 times 1 is 8. Drop that down, negative 8 plus 8 is 0. Okay, so that means 1 is a 0 of this polynomial. Okay, because our remainder is 0. Alright, so because 1 is a 0 of f, we're going to write f of x in our quotient times divisor format. It doesn't matter which one goes first because they're multiplying. So we have x minus 1 times x squared plus 6x plus 8. And that x squared plus 6x plus 8 comes from these numbers here. Remember, those are the coefficients of your quotient. Alright, so now we want to factor the trinomial x squared plus 6x plus 8 so that we can get all of our linear factors. Alright, so x squared plus 6x plus 8, we need numbers that multiply to be 8 and add to be 6. So that would be 4 and 2. So that would make our factors x plus 2 and x plus 4. And then that will make our zeros x plus 2 equals 0, so x must be equal to negative 2. X plus 4 equals 0, so x must be equal to negative 4. And then don't forget, we also have this x minus 1, which we just found out was a factor. So x minus 1 equals 0, so x must be equal to 1. So if we write f of x in our factored form, we have x minus 1 times x plus 2 times x plus 4. And then the zeros are 1, negative 2, and negative 4. All right, I'm going to stop it right here and start another video.